So I hope I'm audible to everyone, and I have another plan. And plan is like from today, I will be solving one problem day in daily manner. Okay, and okay, so here is a problem like a top 60 problem from the lead code. Okay, and I will solve one problem per day, and I will just uh, put that videos on my channel. And so let's uh, let's know about the problem, how many topics I have covered in upcoming days. So this is a link like we got a link from a site like medium.com. Okay, so in this site, a person who collected topmost like top 60 problem of lead code, and it's like a chapter wise. Okay, so just showing how many chapter is. Okay, so this is a chapter we will cover in next few coming days like linked list, stack, heap, priority queue, hash map, and graph, DFS, BFS, tree, and yeah, this is like important DSA and also algo part. So today we will solve a problem from the linked list. Okay, so we will solve the first problem, and problem's name is linked list cycle, this one. So let's jump to the problem. So this is a problem, linked list cycle, and in this problem uh, we have given a linked list. Let's suppose in this format. Okay, so we have given 3, 2, 0, and 4. Okay, and another no pointer from 4 to 2. So if you observe that, so we directly it is easier to identify in this linked list. We we find a cycle. Okay, so in this given problem, uh, this is a simple description like we have to find like if in this linked list cycle is present or not. So in this linked list cycle is present because 4 to 2 it's create a cycle. Okay, and so let's another example. So in this example we have 1 and 2, 1 and 2. Okay, so it's also create a cycle because cycle means if we reach the initial point where we have to start it, like suppose initial point is 1, and after traversing a linked list we again reached at 1. So we can say that uh, the 2 2 to 1 will be create a cycle, and we will return true. Okay, so so we should move to the approach part. How can we solve this problem? Okay, so in this problem there are uh, many approach to solve this problem. So okay, we will discuss one by one. Okay. so so first method is it's a naive approach. Okay, and in the naive approach, what can I do in the naive approach? Because let's we have given this linked list. Okay, and if we have to find whether the given linked list is cycled or not, so what can I do? Like for every node we can check if we can revisit again or not. So from 10, if you check for another node like up to 15, so 50 will never reach 10. Okay, so 12, and 12 is also never reach 10, because there is a no link which is present between 12 to, like, there is no link present between 12 to 10, so that we can say that there is a uh, no cycle included 10. Okay, so let's jump to the another node, like 20, and we will also check for 20, but 20 is also not connected with 10, so we can say that for like, if we include 10, so it can't be created a cycle. So similar this process, if we at reset the 15, okay, and we will check either we can revisit it again 15 or not. So there is a path, like, in this path we revisit 15, so we can say that it's create a loop. Okay, and if we find in the given linked list we have a loop, so immediately we will return true. Okay, so but this is a naive approach, and also it's take big of n square. Why it's take big of n square? Because for every node we will check for all another node. Okay, so it will be take n square. Okay, so yeah, interviewer may be asked to optimize your approach. So we will move to the another optimization approach. Okay, and in this optimization approach, what can I do? Like, if we have a let's take example, earlier example, like 10, 15. Okay, I am writing down here 10, 15, 12, and 20, and 20 points to 15. So what can I do in this second method? We will take a pointer, like, okay, uh, take take this example, like, this is also similar to this one. So in this example, we will declare another full visited, to check whether uh, whether that node will be visit already visited or not. So if you traverse the linked list from the head, okay, and it is a head pointer here, and if you traverse from here, so uh, one is not visited yet, so we mark uh, like already uh, in the initially uh, one is marked as false. Okay, so we will check, we will just make it's true. Okay, and then move to the another next node. So we will check 2 is already visited or not. So here 2 is not visited, because in the 2 there are false value, so we can simply say that 2 is not visited. So we will move to the next pointer. Okay, and we will also change to false to true, because we visited 2 yet. So at the we will reset the 3, and we also check here whether 3 is already visited or not. But here 3 is not visited yet, because the visited value is false. So what can I do? We can change to false to true and move to the next pointer. Okay, so also check for the next pointer, it is also false. So it is also sure that it is not visited yet. Okay, so we will change to false to true. Okay, so after the next we reset the 2. Okay, and if we reset the 2, then we can observe 2 is already visited. It's mean 2 is already visited, because the boolean value of visited is true. Okay, so in this case we will return true. True means, cycle is present. Okay, and But yeah, it's also okay. We will talk about the time complexity. So time complexity of this approach is big of n. Okay, big of n. But what is problem in this approach? The problem is we here we modify the linked list. Okay, so maybe interviewer will be not happy for that because we modify the linked list. Okay, so they also ask like optimize a approach without modification. Okay, so let's move to the another approach. Okay, so this is also a approach to solve this problem. So what can I do like in this approach? So in this approach, we can take a dummy node like which name it stem, and for every node we pointed to temp. Okay, and like in this way we pointed to 10 for we have to just remove this link and join to this link. Okay, for similar for all nodes. Okay, so during this process the only one condition we will check whether the next pointer, like if you reach at the 20 and 20 is pointing to 15. Okay, so the 20 next address is same as the 15 because they are pointing to 15, and 15 is already pointing to 10, so that we can easily say that it's create a cycle. Okay, so in this approach we can show that it's create a cycle. Okay, but it's there is also a problem in this approach. We modify the link. So interviewer is also may not happy for this approach. So at that time they also uh, they also tell optimize this approach without any modification in linked list. So okay, so we will jump to the another method which is most important, and it's also feasible for this problem. So what can I do in in this approach? We can take two pointer. Okay, so we can take two pointer, and first is slow pointer, and second one is fast pointer, and we will move second pointer to one step, but we will move fast pointer to a step. Okay, and it's also known as a Versal cycle deduction method. Okay, so in this problem, like uh, we are using two pointer and which pointing to head. Okay, and like this this pointing to head, and every step like for every step we will uh, move to a slow pointer to one step but fast pointer to a step. Okay, so in this process we can also like increment the pointer like this way. uh, s is pointing to head, and let's take a same example here. Describe. So 10, 10, 15, 12, and 20, and 20 is pointing to 15. So S is here and first is here. So after the first iteration, S come reach to 15, and F reach to uh, because it's take two a step, so it's reach at 15. So after the one step, they will meet, like this is S pointer, this is first pointer. So uh, when S is equal to F means S and also slow and also fast pointer is reached at the same node. So that node will be create a cycle. Okay, so if any question will be if any question they will ask, find that node which creates a cycle, so we will simply return either a slow pointer or the either fast pointer node. Okay, so and okay, so we will if you talk about the time complexity, so time complexity is big of n, and the benefit of this solution is we we don't change their links. Without changing their link, we detect the cycle. Okay, and if we find uh, any node which has like slow and fast pointer list, so that case cycle is created. Okay, so let's jump to the code. So this is a simple code. Like I've already explained the code, explained the procedure in the explanation part. So this is a base case. If head is equal to not, so that case there is a no cycle present, and we will take slow and fast pointer here, and every step every step we took some operation like fast is equal to fast. I mean, mm, we will increment fast by two uh, two position and slow by one step. In fast two a step and slow one step. And if any times and any iteration, if slow is equal to fast, so it's sure that like it indicates that we get a cycle in a linked list. And otherwise if we didn't get it, like in this situation, this condition fast is equal to slow, so that cases there is no cycle is present in a linked list. Okay, so thanks.